Okay, so guys, so today, okay, what you're going to look into is classification of robots. Okay, so how they are classified. Okay, and based on their classifications, you can decide, okay, what kind of robots are required to fulfill your objective or what are required for your problem statements. Okay, so this session is about classification of robots. So these robots, okay, they are classified into 5 different types. Okay, the first one is by applications. Okay, you try to write down, okay, what is your objective or what is your need of having a robot. Okay, what is the purpose, what function it is basically going to do. Okay, and based on that, you are going to select the robot. Okay, that is by application. And you also have by coordinate system. By coordinate system, okay, that it has different, coordinations. Okay, Cartesian, cylindrical. Okay, probably, it has more than that. There are different coordinate systems. Okay, which I'll be teaching you. And your third one is by actuation system. So you will also learn the different types of actuation systems that exist. Okay, and your fourth one is by control method. And your fifth one is by programming method. Okay, so we did see in the earlier class, we're going to learn something called robot programming. Okay, so this is your by programming method. Okay, so these are your 5 different classifications of robots. Okay, based on this, you are going to classify your robot. Okay, the first one is by application. Okay, by application. So when I tell by application, okay, you have 3 types here. Okay, your first one is your common welding robots, right? Welding robot. So what is this welding robot do? This tries to combine 2 metals for you. Okay, and your next one is your assembly robot. Okay, you have different sensors, you have different devices. Okay, you try to combine them together or assemble them together for a single purpose or a function to be completed. Okay, and you also have a heavy duty robot. Okay, these heavy duty robots are the one which are used in the industries. Okay, so by application, you have 3 types here: welding, assembly, and your heavy duty robot. Okay, so what do these robots accomplish for you? Okay, these are the ones. Okay, they try to compete with features like when you need, like maximum speed. Okay, maximum speed. Okay, it helps you to have a good accuracy or to increase the accuracy for you. Okay, these are the factors which are incorporated. Okay, when a welding robot or an assembly robot or a heavy duty robot, okay, is taken for consideration to be worked with. Okay, so these are the few factors which are incorporated. Okay, so this is about your application robot. Okay, and your second one is your coordinate system. Okay, so I hope you know what coordination is. Okay, okay, by coordination system. Okay, so you have different types here. Okay, probably you would have heard about, Cartesian, right? Cartesian, your cylindrical. Okay, these are all different coordinations. There is spherical. There is anthropomorphic. There is gantry for you. And you also have SCARA. Okay. I mean, like these are the very few coordination systems which I am mentioning to you. Okay. So how does this work? Okay. You have a robot. Okay. A robot has to go your objective. Okay. Your objective here. Okay. Your objective here is to pick a board. Okay, a board, okay, or a chalk piece, okay, whatever it is, the objective is here, okay. So for this board to be picked up, okay, this electromagnetic device, okay, which is your robot, will have to move, right? This electromagnetic device, which is your robot, will have to move, okay. This movement, okay, this physical movement, okay, what happens here, okay, this physical, when I tell a human moves, okay, on the contrary, okay, let me just talk about, humans, okay. When I tell a human is moving, okay, when I tell a human is moving, okay, what are the parts of the body, or how does it happen, how does this function happen? Okay, all the muscles tend to move, right? All the muscles tend to move. Okay, so when I tell a human is going to pick a object, okay, when a human is going to pick a object, for that function to be done, okay, that human will have to move the muscles, right? So here, this electromechanic device will have to move, that is, go for a movement, okay. This movement, okay, this movement involves physics, okay, your physics as in which I told you, like probably in your first class, okay, it would involve kinematics, okay, kinematics, okay, your velocity, your forward kinematics, your inverse kinematics, okay, all that, okay. So these tiny movements, okay, these big movements, okay, to create this, okay, these physics, this kinematics, okay, this motion, all that, you need to create tiny movements or tiny movement of these devices, okay, which are called as Cartesian, cylindrical, spherical, okay, there are different movements, okay. Based on this, okay, the movement of the device will be decided, or the function of the device will be decided, okay. So we'll watch a small video, okay, a small video which will help you to understand the kind of movement that I'm talking about, which will also help you to understand the coordination system. Okay, what exactly am I telling when I tell coordination? Okay. Okay, so as you've seen, okay, I hope you were able to have a, a basic understanding of what I'm meaning by coordination, okay? So like I've told you, when a function or objective is given, okay, for it to be implemented, okay, these tiny moments of coordination will have to be taken into consideration, okay? So, okay, and your next one, okay, we'll be moving on to your third one, okay, that is your actuation system. So how does it help you? Now you are able to, classify a robot based on the application which you need. Okay. I need for probably the application which I need probably the assembly robot. Okay. I'm going to select it, and what coordination system will it require? Probably it will require cylindrical or spherical. Okay. And it could also be anthropomorphic. Okay, so all that, okay. And the next one is, what kind of actuation system should I be using? Okay, so coming to your next one, okay, that is by actuation system. Okay, so what do you have here? You have three types here. Okay, the first one is pneumatic. Okay, so what does this pneumatic means? Okay, or the example, okay, to give you a clear, okay, understanding of where it is implemented. This application is done in factory floors. Okay, you will find them in factory floors. And your next one is hydraulic. Okay, hydraulic acid, what is it? This is used for heavy applications. Okay. And your next one, okay, your next one is electric, okay, which is probably very common these days, right? Your electric one is very common, okay. And the next one which you'll be saying is by control method. Okay, so what does this control method mean? You're trying to decide. I did tell you, right? You develop or you start making a robot. Okay, everything is done. You put in the sensors, everything. End of the day, where is the control, right? You are if you are going to create the robot, okay, the control should lie within your hands, within the hands of the maker. So here you have different control systems, okay. The first one is, okay, servo or non-servo control. Okay, you either decide any one. Okay, what does this servo mean? This means there is a closed loop. Okay, so what does your closed loop mean here? Okay, it clearly means that it is both hydraulic and electric. Okay, if your function or your device requires, a closed loop system, you can use servo. Okay, non-servo as in it clearly means, okay, it is a open loop. Okay, so what is a open loop? Open loop is pneumatic. Okay. So if you're trying to consider automation for pneumatic systems, okay, or for open little, I need an automation system for either open loop or pneumatic system. It clearly means you're going to take a non-servo controls, okay. And the next, you have another control which is called path control. Path control, okay. So when I tell a path, okay, it means there's going to be a continuous path. Okay, what does path clearly mean? A path means, okay, it is going to connect to different, okay, methods or different functions. Okay, so here it has been mentioned as continuous path. Okay, when I tell control path control, there is a continuous path, okay, where you're going to place your trajectory. okay, to help you form a continuous path. Your example for this could be your welding systems, okay. And your next one, okay, your next one is by programming method, okay. So what does this do? The programming method, okay, when I tell by programming method, okay, there are different programmings here, okay. I'm not talking about the code, okay, the coding system, okay. I'm talking about something called online programming, okay, online programming and offline programming, okay. Okay, online and offline, okay. So what is the purpose of using online programming? Okay, you get to have a direct use of the robot, okay. You are there, okay, in existence, okay, as a physical person with the robot, okay, and you can go for online, you can do the programming, okay. And your this what will it also enable you? It will also enable you to handle the teach pendant. Okay, what does this mean? Okay, direct use of the robot and teach pendant. Okay, so what happens here is when there is an online programming, okay, I could simply give you the example is your sensors, right? You have your sensors which are programmed, okay, and placed in your robotic device, okay. When the user wants to properly perform a function, they can give a command, okay, and they do not have to interfere with the robot, okay. The physical person, the user does not have to go meet up with the robot, okay, switch on a system or a button or whatever it is, okay. The sensors are inbuilt, everything is connected, okay, and probably with a click, okay, or a sending of a command, okay, the action will be done completed by the robot, okay. That is the direct use of the robot. Teach pendant is, okay, this is a trained system, okay. Teach pendant is a trained system, okay, as in, okay, a trained system would have been trained with certain tasks, okay. It has already been trained, okay, and tested, okay. So this pendant, okay, could be a sensor, okay, either a sensor, okay, or a programming interface, or a programming interface, okay. When enabled, it will just help the robotic device to complete the task, okay. So the main benefit of your online programming is the user will not have to, or there is no need for the user to be present, physically in the environment or the surrounding, okay. But when you tell offline programming, okay, offline programming, you are going to basically use a computer, okay. It means you are not having a movable robot, okay. It is an immobile robot where there is a computer, okay. And when you assign the task to the computer, it will pass the commands to the device, okay. After which the task, okay, when the commands are given to the computer, the new task, okay, the new task is assigned. The new task is assigned, after which, okay, the task is assigned to the computer, okay, and this task will be downloaded by the robotic device, okay, after which it will be implemented by the electromechanical device that we are trying to develop, okay, or that we have tested and we are trying to function it according to our objective, okay. So these are the difference between your online programming and your offline programming, okay. So like I've explained, like 5 different methods, okay. So how do you put that into practice? Okay, I'll just give you a comment. Okay, our problem statement. Okay, probably your problem statement here could be to just the common one. Okay, pick up a pen or a pencil or an object. Okay, this is your common, this is your problem statement here. Okay, so what would you do? How are you going to select your robotic, that is your electromechanical device? First, the thing you're going to look into is, the first thing we saw is application, right? By application, okay, what kind of robot are you in need of? Right, we saw three different applications: welding, assembly, and heavy duty robot. So when I tell pick up a pen, probably I could just cross it out. I can have it as pick up a object. Okay, I'm going to train a system, a new system, train and testing. So pick up a object. So when I tell I need a heavy duty robot, okay, because I may not know, it could be a pen, okay, or it could be a 100 lb package. Okay, so I'm going for the heavy duty robot. Okay, and the next one is I should decide the coordination system, right? So what kind of coordination system would I require when it is a heavy duty robot? Okay, I would go for the anthropomorphic. Okay, and the next one is the actuation system. Okay, so what kind of actuation system do I require for this anthropomorphic coordinate system is that, okay, I would require hydraulic, or it could be electric, right? So I would take up hydraulic since I'm opting heavy duty robot. And the next one is by control method. So what kind of control do you think lies? Okay, so I should be deciding here. I've already mentioned that I'm going to use hydraulic. Okay, it means I'm going for closed loop, which means I need a servo, right? I need a servo control. And the last one is a type of programming. Okay, so this is a heavy duty robot. It clearly means, okay, there is no online programming. Okay, I am opting for offline programming simply for the safety purpose. Okay. Okay, so this is how, okay, this is how you decide which device, which electromechanical device, or how these different types, or how do you decide based on your applications. Okay, this is how you do it. Okay, so I hope probably end of the session you are clear. Okay, when a problem statement is given to you, you are clear on how to select your robot based on the application, the coordinating system, okay, its actuation systems, how to decide the control method based on your problem statement, and also to understand how to program them. Okay, I hope you're clear with this. Okay, for the classification of robots, in the next session you can look into the next part. Okay, about the components of these robots, how which components helps you in different functions, in accomplishing different functions or actions, so that you also know what components are required for what tasks. Okay, as of now you're able to tell, you will as of by the end of this session you should be able to tell when a problem statement is given, you should be able to classify the type of robot that you need. Okay, you should be able to classify the type of robot. Okay, next session you will look into the components of robots. Okay, why? Because knowing the components will help you to design. Okay, design the robot or the electromechanical device based on the action required. Okay, so this is all about the session. Okay, guys, so we'll meet up in the next session.